Hello guys, my name is Tu. So welcome to another video. On this video, I'll be talking about how can we do robot animations using plant simulation software. So whatever animation that you would like to do, which includes the hinge joint and also slider joints, such as a 6-axis robot or a SCARA robot, is quite we can do it in a systematic way. But if your robots or if you have any animation that you would like to do in spherical joint or ball joints, that will be much harder, but it is still possible, just that it is requires more effort. So nevertheless, on the screen currently I'm showing you that I have custom robots with me from KUKA. So the KR600. So as for your information, plant simulation software is logistics simulation software. This discrete-event simulations tools. For robot simulation, yes, it can do it, just that it is not a proper CAD package. So if you are trying to handle the CAD, the 3D geometries, the 3D graphics, I would always recommend to use an external tool such as NX software, for example. So let me just head over to the NX software here, and I'm going to open up the neutral format. So I'll go to open up stat file KR600 and R2830. Okay. So depends on how is the files or the graphics are arranged in the file. Currently this file is all located within one hierarchy. There is no hierarchy differences, and therefore we need to take note about that. Sometimes when you import the stat file, you will get different setting, different configuration. Then you will need to know how is the methodology to work with it. So I'll quickly show you the graphics in the part navigators. So these are the discrete graphics. Each of the graphics are highlighted as below. You can see in the screen. So everything is lumped together, thus making the animation seems to be a bit difficult to distinguish, like joint 1, which graphic should move in joint 1, which graphic should move in joint number 2, joint number 3, and so on. So we'll be using the hierarchies to help us to distinguish the joints. Therefore, we'll be using assembly structures. So depends on what CAD package that you are using. I will always recommend to use CAD assembly structures to help you to distinguish joint 1, joint 2s, and so on. So for that reason, I will navigate over to my assembly navigator. As you can see, currently it is empty. I will quickly create some structure over here. I will use the assembly tab and create a new component under here. And the first component that I would like to use, and before that, probably for animation wise, we'll try to remove those parts which is flexible, such as the tubings. So these tubes are difficult to animate, and therefore for simplicity purpose, I would remove them for now. I'll just delete all these tubes. Okay. So probably this is a secondary animation. Definitely we can also include secondary motion or any dependence on those main animations. So these secondaries, yes, we can include, but for simplicity purpose as well, I will just remove them for now. Okay, so I will just quickly distinguish which part that I would like to put to a second structure. I will just hide this geometry. Okay, starting, I can clearly see that everything above will be included in the first joint rotation. So I will click this button again, select, I will filter out all the solid geometries that I would like to select, all the solid geometries only, select everything above and click OK. Therefore I will have a new structure or hierarchies over here, and I'm going to name it as joint number 1. Okay, J1, save. As for the parent, I will just keep it the original name as such. So these are all in joint 1. That is to say, if I try to do some motion over here, let's say I'm trying to move joint 1, everything will move together. Just that I will need to carefully identify the center of rotation, such as this one, this point over here. Once I have identified it, I can quickly try to test the motion. Just this is very basic, just to let you know that everything within the same hierarchy will move together, and thus this is animation friendly. Okay, we'll just cancel the operation for now. Discard the changes. Okay. Now let's move on to J1. So we just continue to make this as the to further distinguish the hierarchy. So I'll move forward to work with J1, and I'll quickly remove or hide the geometries over here, and probably hide this geometry as well and this geometry as well. So everything above will be in the sub hierarchy as well. So again, pressing this new component, choose over here, OK. And thus I will have a sub structure over here. For this I will be naming it as joint number 2. Okay. As for the parent, I will just keep it as it is. Cancel. Now let's head over to joint number 2. Double click. I'll just hide this geometry, and this one I will just remove it because those are the flexible component. And here I will have joint number 3 with me, so I'll just click again, separate it out, distinguish the hierarchy, select all this geometry and click OK. Okay, so all this will be saved as J3. Okay. Then for J number 3, again we can further distinguish the joints. So I'll just hide this component. Okay, so everything here will be moved down one hierarchy level. Again, pressing and choosing this geometry. So this will be J4. Okay, so now I have J4, and I will just stop for now so you understand what I'm the more important thing is you understand the concept on how to condition your geometry, your graphics, before you send the graphics into the plant simulation software. So this will be, obviously there is another joint over here, J5 and also J6, but I will just stop here because I hope you understand how can we further just include the animation stuff. Okay, so now let's come back and show everything. So I'll just quickly show everything here. Now, how can we further condition the geometries? First of all, we need to make sure that the origin of this geometry is always at the 0, 0 position. So to see the 0, 0 position, we can quickly create a datum coordinate system. So let's say this guy. Okay. So this will be the 0, 0 position. And when I try to check the position of my robot, just to make sure that the robot is actually sitting at the 0, 0 position as currently shown. So you can always reposition your graphics so that it is actually sitting on the 0, 0. So this is actually a very convenient way to do it here, because once you're in the plant simulation environment, it is very difficult to identify the coordinates. So moving on, we can go to J number 1 as well. So let's head over to J, the first join. So this is the first join, and we'll quickly identify the 0, 0 position as well. So notice that the absolute coordinate is at the same point over here. So we already have a datum coordinate, but I'll just quickly create one as let's see. Okay, I already have one over here. So the next coordinate that I would like to use is the center of rotation for this geometry, this graphics. So let's create a new coordinate system at the center of rotation as such. Probably at yeah, as such. Then we have two coordinates. Again, my advice is always to put the center of rotation at the origin location, so so that when we transfer the graphics into plant simulation, the workflow will be much easier. So for now, I will just quickly do some transferring. So edit, move object, or this geometry. Okay, move from coordinate, choose coordinate to coordinate is much systematic. Click this coordinate, choose okay, this guy to this guy. Move the origin and check the preview results that the motion is set. Click OK, accept, as such. So we'll need to adjust the children as well. So we'll just go to the assembly navigator and adjust the children hierarchies to move according to the coordinate as well. Move. So again, coordinates to coordinates, here to here. This will be a rather quick. This will be a rather quick method operation. Okay, now let's see. So we need to return to the origins, the parent geometry over here. Notice that everything is now not in the correct position because we have just shifted something down. Therefore, we need to shift it up again using the same coordinate system. So from here, I will select, I will call out the coordinate system, choosing entire part for J1 so that I can see the coordinate system. Okay, and now use the move command, move from coordinates to coordinates. So which is here to here. Okay, so this is now back to normal. So we're going to do the same operation for the rest of the joins. So this is join 1 already conditioned. Now let's move on to join number 2. So move on to open join 2 in a new window. So for join geometries in join 2, we already have the origins coordinate system. Now let's create another one at the center of rotation. So over here, let's choose this guy. Okay. Now let's try to move again. Okay. So for the children, we'll use the assembly move command from this coordinate to this coordinate. Now let's head back to J1. So J1, notice that J1 is a bit messy because the shifting of the graphics, we need to reshift again. So J1, let's see, J2, entire geometries, okay, and we are going to shift J2, move from bottom here to top, as such. Probably I've mistaken it. Let's try to do it again. For J1, I will need to hide the coordinates for now, just not to be confused too many coordinates at the same time. Okay, this will be done. This will be it, and let's try again. Move from coordinates to coordinates. Yep. Okay. Just to check, go back to the parents and check that everything is in the proper arrangement. Now J2 is also arranged properly at the center of rotation, so that the center of rotation is at the origin. Okay. Now again, let's continue with J3. So J3, just to quickly add another coordinate at the center of rotation here. Again, we're going to use the command move object, moving only the solid bodies. Okay, from here to here. Okay, now let's go back to J2. Let's try to hide the coordinates at J2 just using the coordinates at J3. And we are going to reposition J3. But let's go back to J3, and I have forgotten to modify this position, J4. So just move J4 from coordinates to coordinates. Okay, now let's go back to J2. Okay, as such. So let's move J3. Move from this coordinate to this coordinate. Okay, so now let's check again at the parents level. Everything is fine. So J3 is now conditioned. Let's move on to the last join, J4. So J4, we are going to create a new coordinate system at the center of rotation here. Now do the same transfer of the geometry, transfer everything over here, but we choose a solid body and select everything from coordinates here to coordinate here. Okay, now let's go back to J3, and we are going to hide the coordinates of J3. And just to show the coordinates of J4. Okay, and transfer J4 from coordinate to coordinate. Okay, so now check that J4 is now located at the origin, and J4 is now conditioned already. So everything is the CAD is now conditioned. So this is an ideal hierarchy for robot animations. And let's proceed to save this file. Let's try to save it as a step file again. So step file. Okay, we have a new compression. Okay, step file is over here. Step file, and this will be robot. Just put your name. For plant simulation 1. Okay. Now, let's move on to part 2, which is plant simulation. So here we are going to create a new file, 3D, and we are going to create a new class of object. For this case, I'll be using the station class. So I'm just going to hold down my control key and drag this class to a new to this folder over here, because I'm trying to create a new class. So this one, I will just rename it as robot. So when I try to open this class, open in new 3D window, this is obviously not a robot, so I will need to delete everything. Just use the left mouse button to select everything, drag everything, and press the delete key to delete the default graphics. So now I'm going to import the condition geometry from my CAD operation just now. So I'm going to choose import graphics from the edit tools tab. So from here, go to desktop, robot, and Kuka, and this will be the file. Also, I've forgotten to mention to you that because plant simulation will use the z-axis at the top, by default it will use the z-axis as the vertical or the height. Therefore, it is also advisable that you will use the same axis. For example, z is pointing to in the height direction. Okay, so now when this is imported in, you will notice that there is a 2 red line over here. The intersection of this 2 red line is the origin of the frame. Therefore, when we just snap to the origin, this will be a perfect location, because the CAD has been conditioned to put at the origin. As I have mentioned just now, we put the base at the origin of the CAD. Then when we import it into plant simulation, the origin is also at the same location. So obviously we are going to choose the positioning is position origin to the origin of CAD to the origin of plant simulation. Then for the orientation, we will always choose the default, which is z-axis pointing in the height direction or pointing up. And we'll just click OK for now. Notice that if the graphics has shifted outside of the origin point, you can always reposition it. For example, click Edit, right click on and choose 3D properties. And for the X and Y, we'll choose 0 again, including the Z, so that it is now sitting according to the CAD geometries. So you can see that the black color is representing the floor, and the orange color represents the base of the robot. So this is a perfect allocation. Now for this geometry, let's try to define the joints. So we're going to right click and choose Show Graphic Structure. Currently, you will see that all the step geometries are all put into one node. And when I expand this node, you will see that there is a J1 over here, which is catered for everything within J1. And this will be the decoration for the base. So this is very easy to work with. So what we need to do is just right click J1 and choose Make Animatable Objects. And we'll just quickly name this animatable object as J1. And J1 is having a joint, is a hinge joint or rotation joint at the y-axis. As you can see here, is at the y-axis. So we're going to choose here 1, and the center of rotation we can just put it as 0, 0, 0 because we have positioned the center of rotation at the CAD side as 0, 0, 0. Therefore, we are not going to change everything here. Everything, the 0 here is just perfect. And we are going to choose revolute join to represent a hinge join. As for the speed, we can try to put some values over here, but for now I'll just leave it as it is. Preview, let's try to put some value and see the animations. For example, 50 and minus 50 and 50 again. So this is a correct, so that's to say the first join is not rotate at the y-axis but at the z-axis. So we need to change this over here by clicking this this arrow. So now it is now giving me a correct representation. This is a correct animation. So I'll just click OK for now and accept the first animatable joint. Now let's try to go to J2. Let's try to define J2. Again, we're going to expand this 2. Notice that there is one node over here and we have a J2 over here. Again, we will need to dive into J1. So we're going to open J1 in a new window. So this is J1. Notice that how it is arranged at this position over here. You see that this red, the intersection of these two red color lines represents the origin of this frame, and it is perfectly located at the 0, 0 positions where we define the center of rotation in the CAD package just now. Therefore, this is saving us the trouble to define the center of rotation. So now let's continue to define J number 2. Just right click J2, make animatable objects. I will just put the name J2 over here. And for this joint, it is now rotate at the y-axis, so we're just going to choose y over here. Center of rotation, we are not going to change everything because it is again located at 0, 0 point, the center of rotation. So we're just going to leave it over here. Then we choose revolute join here. Try to preview the joint's value, let's say 50, minus 50, and 50. So this is a good preview, so we just click OK. Now let's continue to do the same thing for the next two joints. So I'm going to dive into J2 and see make animatable objects. J3. So this will be rotation in the y-axis, and revolute join, put a quick value inside to see the preview. Okay, as such. Okay, to accept. Dive into J3, and we are going to find J4. So J4, unfortunately, it is a bit messy over here. It is hard to see where is, I believe it's this node. Let's see, it seems that it is not all the hierarchy is breakout, so we need to group all these components together. So what we can do is we can just highlight. So we need to do a drag over here. This is J3, and we need to select multiple geometries here. I don't think we can select that. So I'll try to separate this group. So that I will try to dissolve this group over here to so let's try to dissolve this group, ungroup. Okay. So from here, again, I will choose ungroup again, so that you will notice the change in the hierarchy. Now that everything has been promoted, we are going to select in the graphic window. We're going to select the geometries which is belong to J4. For example, I use a mouse drag and choose everything over here. All these geometries are selected, even though here we can't see the selection is highlighted. So what we do is just we do a mouse drag to select everything over here, and we can choose group to group this geometry into one particular node so that we can make them independent later. So now let's refresh the hierarchies and find that there is a new group called 180. So we're going to right click 180, make animatable objects. So unfortunately, there is some unexpected scenario I'm currently encountered. Therefore, these are some of the workarounds we can try to do if the hierarchies are not to your preferences. So choose J4, OK, and for J4 it is now rotate at the x-axis. So we are going to choose x-axis over here. I'm hoping that the center of rotation does not mess up. So I'm just keeping 0 over here. Revolute joint, and we are going to put a test value, let's say 50. Okay, so it is now the center of rotation is messed up already. So the center of rotation obviously is messed up. Let's say if I choose another value over here, so it is not going to be. So when you encounter this scenario, it is always, my advice is to go back to the CAD package and try to do some workaround to make the hierarchies a better hierarchy again. So let's try to go back to the joints. We are going to test a value, let's say 50 is not correct, so minus 50 is not correct as well. So therefore, obviously the center of rotation has been shifted. So let's say I'm going to put, let's say 0.1. You notice that this is now a bit of guessing, so which is very difficult to modify for here. So for that reason, I'll be just, for this training or this tutorial, I will just keep to 3 joints. And for joint number 4, probably if you are very interested to do more joints, you will need to be careful on how to find the rotation centers, or even you can try to restructure your hierarchies to make it stronger hierarchies before sending into plant simulation. Probably we can also do some CAD cleanup, because just now I did not clean up my geometry, because probably some of the graphics will have broken CAD data, so we can try to clean up the CAD before exporting again. So these are some of the suggestions, but for now I'll just keep to 3 joints and do a 3 joints demonstration. Okay, for this joint I'll just leave it as usual, and we're going to quickly do some animation for the 3 joints. So first of all, we always like to use pose. So I'll just right click on this robot, edit 3D properties, go to the pose, create a new pose, for example home position. And definitely there is other more familiar name. So let's say I'm going to add, for home position, these 3 joints will be used, and we are going to use some value over here. Let's say this will be the position of home, and this will be negative 50s, or this will be I don't know, I'll just put in some random value as such. Okay, so this will be home position, and once this is done, you can quickly see the preview and return it. Okay, so I was just going to put this robot into a frame. So I'll just put it in. Notice that it is now sitting perfectly at the same height of the plane. So I will just quickly do some simple code. So this code is to tell the robot to do a pose. So move to. So let's see, the code is pose, move to, and the pose name is call. Just to make sure it is small letter H, home, as such. And I'm going to create a new method over here. This will be initialization, init. Just rename the name as init, and therefore the graphics will change. I'll just say wait for an hour, and I will start the simulation in real time. Okay, let's start the simulation. It is now running. Okay, it is now running. Then we are going to run this method. Just right click, choose run. Okay, it is now moving gently to the home position. It depends on the speed that we have specified. However, if you would like to change the speed, you can always do it here. So let me just go to the pose keywords to recall myself. Okay, the pose tabbed, and so we can use the keyword move to pose. So this will be the first entry of the information. Time span is the time duration to reach that position. So we can try to, for further understanding, you can try to read up all this description over here. For example, it says 7.5 over here. We take 7.5, and yeah, the time required to go to that location. So let's try to put a value over here. Let's say 2 seconds, and we'll just save. I'll just restart the simulation. It is now running, and click run. So it takes 2 seconds to reach the position. So, and furthermore, if you would like to have more positions, you can just write wait, and then create a new pose. Let's say origin. Then therefore it will just move to 2 positions. Let's try to create a new position named as origin. So pose again at origin, and okay, so origin, everything is just back to 0. Okay, and let's try to restart, run the simulation. So first of all, it waits. After the waits here, we just wait for 2 seconds to complete this operation. Then again, it will back to the origin positions. So this is how you can animate a series of animation for the robot. So thank you for this video. I hope you enjoy it. It is taking quite some time. Sorry about that, and hope to see you next time. Thank you. Bye.